Welcome to this multiplayer basics in Unity 6 tutorial series, where we will learn how to create the simple 3D resource gathering game. Hi, I'm Peter and welcome to Sunny Valley Studio. I will walk you through the process of setting up a multiplayer project. We will create a movement system, connect with other players using localhost and the client-server topology, and implement a simple gameplay of collecting resources that is synchronized across the network. Throughout this video series, I will be explaining multiplayer-specific concepts like what is authority, ownership, and how to synchronize the game state between all the clients that joins our game. You can download the starter project for this video series from my Patreon page, link is in the description. And my Patreons can download the end project version files for this video series as well. Let's create our multiplayer project first. In Unity Hub, create a new project selecting version 6.3 or later and the universal 3D project template. Give it a name and let's create the project. When you have your project opened, the easiest way to install the multiplayer packages that we require is to go to the window, the multiplayer category and select Multiplayer Center. A new tab will appear. Select genre of your game to be the sandbox and the number of players per session select 4. Based on those choices, Unity will suggest the packages to be installed. We want to make sure that the Netcode solution is selected as Netcode for GameObejcts and the hosting model is selected as client-hosted. This means that one client will be a server and a client of the game and the rest will join its session. This solution has its pros and cons, but generally it is budget-friendly because you do not need to have a dedicated server. And with Netcode, you can easily switch to a different topology later on. Below we see the list of packages that will be installed. We want to uncheck voice text chat vvox because we are not going to use it and you can install it later anyhow. With this done, let's click Install Packages. When the packages are done installing, you have access to the quick start where you can create and open a scene with Netcode setup. But we will test our own scene at the end of this video anyhow, so let's close it. Next, let's import the starter project package. When you're done, open the scenes folder in the project tab and open the game scene. Before we get an overview of what is going on here, let's go to the Edit, Project Settings, and we want to find the Tags and Layers category and open the Layers section. And as user layer 3, let's input with capital O outline, and as layer 6 let's put in the interactable. Now the outline layer is important because in our _scripts folder we have this selection outline script that uses this outline layer and depends that it is present in our project. Furthermore, if you select the quality section of project settings and select the 𝗶𝘃𝗲𝗀𝗀𝗀𝗀 asset, the universal render pipeline asset, and select it in the projects tab, you will see it highlighted, but we want to select the 𝗶_render asset, and here if we expand the render object, the render features at the bottom, you will see that I have added 2 of those and they are also using the outline layer, so that we will see the outline on the objects detected by the player in our game. I have a video of how it was created, so you can check it out, the link will be in the description. In our scene we have a very basic map with some trees and some rocks. In the game view you should see 3 buttons: Start Host, Disconnect and Start Client. Those are controlled by the multiplayer UI object in the hierarchy. You will see that it is created using the UI toolkit and it has a multiplayer UI script on it. It will allow us to intercept the click events from those buttons. Now to prepare our scene for the multiplayer, we need to add a new object in the hierarchy. So let's select it, let's press Ctrl-Shift-N to create a new game object. Let's call it NetworkManager. And let's add as a component of it a NetworkManager. This component comes with the Netcode for GameObejcts package, and it is a most important component of a multiplayer game. Think of it as the brain of your multiplayer session. It manages connections between players, keeps track of which objects exist in the networked world, and handles spawning and despawning of network objects. It allows us to start a server, start a host, and start a client, and connect to a multiplayer session. Back in the Unity Inspector, if you take a look at this component, you will see that at the top it states that our network topology is client-server. In this topology, the server acts as a single source of truth and stores the game state, and the client, so the players, connect to it, and they send messages to the server and receives a state update from the server. With this selected, we need to go to the Select Transport dropdown. Because we have this yellow exclamation mark, we need to select here the Unity Transport, and a new component will be added at the bottom of our inspector. The transport component defines how different clients in our game will communicate with each other. In the inspector, you can see that it defines different parameters of our network connection, including the local host address and the port that we will use for the connection. To test our project over the network, you would have to modify those parameters. We can use the multiplayer session Unity building blocks, the free asset from Unity, to test our game over the network. If you grab the end version of the project from my Patreon, this is already implemented in it. In this tutorial, we will focus on implementing gameplay mechanics over the network, so we will use the local host to test our project. Now, in the NetworkManager component, we can specify the default player prefab, so it will spawn a player game object for each client who joins our multiplayer session. To assign this field, let's find the _network prefabs folder in the Projects tab and open the player prefab. In this video series, we are using 𝗾𝗂𝗲 models that are CC0 licensed. If you open the prefab, you will see that we have the main player object with a character controller and the agent mover script. This script is a mono behavior similar to what you would use to move the character controller in a single player game, and I will explain why that is so in the next video. Basically, it will rotate the character and allow it to move in the direction that it is facing, and it will also trigger the movement animation. Besides that, we also have the mesh object with the animator component on it and the animation event script that will help us get the events from the animator and process them in our own script. And we have also the audio source that will play the step sound. Now the sounds are all taken from the freesounds.org website, and all of those are CC0 licensed. All the animations are already implemented so that we can focus on working on the multiplayer gameplay logic. In the prefab, we also have a UI document that will show us the name of the character in our game. We are going to implement it later, but it is also a UI toolkit UI document with a billboard UI script that will just make sure that the name always faces the camera. What we need to do is select the parent object of our player and add to it a NetworkObject component. The NetworkObject component marks a game object as part of the multiplayer session, meaning its state can be synchronized across all connected clients. So a static element like this grass doesn't need a NetworkObject component, but the player object that influences the multiplayer session needs one. Currently, the settings can stay as they are, and all we need to do is exit this prefab. Let's select again our NetworkManager object and make sure to assign our network prefab player as the default player prefab. NetworkManager also has a network prefabs list which contains all the objects that will be used and synchronized in our multiplayer session. If the prefab is not on this list, the network manager won't know how to spawn it, and the other machines will not know how to synchronize it. Besides that, the network manager allows us to start a host, start a server, and start a client. Host is acting both as a server and is also participating as a client in our game session. To test our game, we need to connect our start host and start client buttons to call those methods on the network manager. To do that, let's find the _scripts folder in our project tab. Let's right click, create a new mono behavior script. and let's call it GameManager. Let's open it up. In a single-player game, we create monobehavior scripts, but in a multiplayer game, we need to inherit from the network behavior instead. Doing so will give our script access to different features like synchronization of the state of our game, messaging system, so being able to ask the server and receive a response from it, and know if we are the owner of the object or if the server is. So in our script, we need to change the monobehavior inheritance for network behavior. For it to work, we would need to add using unity.netcode at the top. In the script, we need to add a reference to our multiplayer UI script that I have provided for you. Let's call it m_multiplayer UI. This script accesses the buttons of the UI document and exposes the onStartHost, onStartClient, and onDisconnectClient event actions. In a network behavior script, we can still use a start method and assign our own methods to the events of our multiplayer UI object. So I have assigned to the onStart plus equals startHost, onStartClient plus equals startClient, and to onDisconnectClient plus equals disconnectClient. In Visual Studio, we can right-click on it, quick action, and generate those methods so we don't have to type them by hand. Let's go to the first method, for example, to disconnect clients. I want to access m_multiplayer UI, and we should have disable buttons method, which in our case will disable the host button and the client button, but it will enable the disconnect button, and the enable buttons method will do the opposite, enable the host and client buttons and disable the disconnect button. Now we are inheriting from network behavior because it exposes the NetworkManager property, giving us access to the NetworkManager object that exists in our scene. So in our disconnect client method, we can call NetworkManager, and this is how we access it, and we can call shutDown, which will shut down the connection. In the start client method, we are going to call m_UI multiplayer UI dot disable buttons, and we are going to call NetworkManager dot start client, and below we do the same but call instead start host. When we have all those three methods, let's save the script and let's go back to Unity. In the hierarchy, let's use Ctrl-Shift-N to create a new game object. Let's call it GameManager. And let's drag here our GameManager script. It will prompt us that the GameManager does not have a NetworkObject component. And since it inherits from network behavior, for it to work, it needs to have a NetworkObject. So let's click Yes in the prompt, and we need to assign the multiplayer UI reference. So let's drag our multiplayer UI object from the hierarchy here. Now let's save our scene, but to test it, we would want to have a second client. And for that, we want to go to the top menu, Window, Multiplayer, and Unity provides for us a multiplayer play mode, which allows us to simulate up to 4 different clients as separate game windows. So let's check the player 2, and if we wait a bit, it will open a second game window. We can change the aspect ratio of it, and now we can test our game by simply pressing play. We may see additional message, add scene to scenes in build, and it wants the scene that we are playing right now to be added to scenes in the build list. We would want to say yes to that. The same message should show up for the client too, so say yes here as well. And we have some warning messages. They are about the NetworkManager and how we have added, it is actually in the don't destroy onload, how it has added to our network prefabs list all those prefabs that do not have the network object component on them, so the network manager is removing those prefabs. We can remove them manually later. If we take a look at the file build profiles and check the scene list, we will see that our game scene was added to it, and only this way we can test our game using the multiplayer play mode. Now, we should be able to start a host. Make sure to start host first in our game view of the editor, and let's start a client in the other game view. Now the scene looks the same, albeit we have the player being spawned. But where is the other player? Well, if I minimize the game view of my editor and take a look at the hierarchy, you will see that we have two player clones. So if we take a look at a player clone and focus on it and move it, we will see that it moves in the game view of the editor but doesn't move in the game view of the player 2. Let's try moving the second one, and the same situation. This is because we are yet not synchronizing the position of the players, but you can see that we already have two character objects being spawned because we have two players connected. Let's use the disconnect button, and you should see one of the character objects disappearing from the game view of our editor, and this is because our player 2 has disconnected. In case you experience some difficulties making player 2 to work, the easiest solution is to reset it, so disable it here in the multiplayer play mode and re-enable it again. The most important thing is that we know that our setup works and we can start developing our game. Before we do that, I will select the default network prefabs list and remove those objects that I have added previously. They will have network objects and will be added automatically to the default network prefabs list, but for now we can remove it to avoid those informations from the console. In the next video, we will add player movement, get input from the player, and learn about server and client authority. If you're enjoying this video series, please be sure to like and click that subscribe button. Also, thanks a lot to my Patreons for supporting the channel. See you in the next video.